This section is about energy and how we can't keep hold of it. You jump off a great height, accelerate to the ground, land on a giant spring and rebound again. At the start of the motion, you have gravitational potential energy, mgh. As you fall, you lose it as you lose height, and as you speed up, you gain kinetic energy instead. Your kinetic energy is given by half your mass times your velocity squared. The spring slows you down as you compress it, and you give it elastic potential energy, which depends on how stiff the spring is, K, and how much you compress it, X. The spring uncoils and propels you into the air again. You gain kinetic energy first, and then more and more potential energy as you climb higher and higher. The first law of thermodynamics states that energy cannot be created or destroyed. Energy in equals energy out. However, on your rebound, you don't get back to the height that you started at. You've lost energy. We know that energy can't be created or destroyed, so it must have gone somewhere. But where? We've already talked about drag. If you push some fluid, air, out of the way whilst falling through it, you put a force on it. We've also already said that moving a force through a distance is called doing work, and work is a form of energy. So some of your potential energy goes into doing work on the air. What about the spring? Once it has propelled you back into the air, it will either have kinetic or potential energy that it didn't have before you interfered with it. You've transferred some of your energy to it and not got it back. So some of your energy has been transferred to the environment around you, where it will disperse and dissipate. This spreading out of energy comes from the second law of thermodynamics, which states that natural processes are irreversible and tend towards a state of maximum entropy or disorder. A cup of tea will cool down as its heat energy radiates away. It follows from the second law of thermodynamics that the universe is condemned to a heat death, where heat is eventually spread evenly throughout space and there are no longer any thermal differences from which work can be extracted. Life, on the other hand, is sometimes described as the organizing principle that captures energy from the environment, temporarily and locally going against this march to maximum disorder. When you jumped from a great height, we saw a similar thing. Your gravitational potential energy was organized and all in the same place, but by the end of your first rebound, you'd lost energy to the air and the spring, moving towards greater entropy. Before we finish, let's think briefly about where our energy comes from. For example, where did the energy come from to get you to that great height in the first place? Well, it looks like you climbed a ladder, so your brain and muscles did that. That's electrical and mechanical energy. And to do this, your body burned fuel, releasing stored chemical energy. And where did this chemical energy come from? Let's say it was an apple. All of our food energy ultimately comes from plants, and they use photosynthesis to capture light energy from the sun. So, the sun's energy got you to the top of that ladder. So we've seen that we can have energy in many different forms: kinetic, potential, mechanical, chemical, electric, elastic, light. Finally, let's compare things, put some numbers in. Consider three things with energy: a peanut, a AA battery, and you just before you jump. Let's pretend that your mass is 60 kilograms and that your ladder is 5 meters long. Which do you think has the most energy? You've got a gravitational potential energy of 2,943 joules. The battery has an energy of 10,000 joules, so if you ran efficiently on batteries, you'd be able to climb to 17 meters. What about a peanut? Does it have more or less energy than a battery? Well, a peanut has about 6 food calories, which is 25,000 joules of energy, more than the battery or your GPE. So if you could efficiently convert a peanut's energy into raising your gravitational potential, you'd be able to climb to a height of 42 meters. Energy cannot be created or destroyed, but it does get lost to the wider environment.